So are all your friends awesome astronomers, or what?
Not all of them. Jesus is a really good guy too. But now we're in the year 1630 in Germany to meet one of the smartest astronomers and physicists of all time. Joe?
Doppler, long time no see, my friend.
How's everything going? This is my friend Jeff that I was telling you about.
Jeff, nice to meet you.
Meet you, sir. You're Johannes Kepler, right? You trained under Tycho Brahe?
Yes, that's correct. Tycho hired me as his assistant. I used a lot of his data when I made my observations.
So what did you observe?
So the first thing that I did was abandon uniform circular motion, which was in place for about 2,000 years prior. When I was making my observations, I realized that the motion of the planets was not as simple as people may have thought. But then again, I am a master in geometry, which made my predictions extremely accurate.
And what exactly did you predict?
Well, Jeff, I came up with 3 laws in the field of astronomy, which were widely accepted as the new structure of the universe at the time. My first law claims that planets orbit the sun in an ellipse, not a circle, with the sun at a focus. This is pretty controversial at the time, but if you take a look at my calculations, it was impossible to disprove it. My second law was that a line that connects a planet and the sun sweeps out an equal area over equal intervals of time. And my third law is that the square of the orbital period of a planet is directly proportional to the cube of its semi-major axis.
Okay, that all makes sense. But what exactly is a semi-major axis and a orbital period?
So the orbital period is simply the time that it takes for a planet to make a complete orbit around the sun. And the semi-major axis is essentially the radius of any given orbit at that orbit's most distant point.
That's great. Thanks so much for your help, but I have to bring Jeff to see a couple of my other friends.
Don't forget, Jeff, all these discoveries and all other scientific findings are a credit to God.
Okay, I'll remember.
Thanks again.
Bye, Doppler.
Thank you.
Nice to meet you, Jeff.
Pleasure to meet you. Wow, that was pretty interesting.
Yeah, I mean, he's not one of the smartest astronomers for nothing.
Alright, so who's up next? Let's go.
Let's go.
Now where are we?
We're here to meet with Galileo Galilei. This is a private study, so be curious.
Sorry. I think I actually heard of him. He in lecture once.
Great, well, let's go meet him.
Cool.
Galileo, how are you?
Oh, how are you, old friend? Yes.
Why have you moved to Florence?
Well, I've actually been on house arrest since the Inquisition in 1633, so I'm still waiting for that one to kind of pass.
Oh, wow, I'm sorry to hear that.
Yeah.
What'd you do? Why are you on house arrest?
Well, I've been advocating a heliocentric model of the universe, similar to that of Copernicus, and the Catholic Church tried me for heresy, for saying that the sun is motionless at the center of our universe.
Oh, well, did they have any proof that you were wrong?
Well, the Church cites the Bible that says the sun rises in the east and sets in the west, but I think those aren't meant to be read literally and as scientific fact.
Oh, I'm sorry to hear that. Just one last question for you. So did you actually invent the telescope?
Contrary to popular belief, I did not invent the telescope, but I did improve upon it, and I was one of the first people to use it to observe the sky and the stars. That's what helped me to discover the 4 satellites of Jupiter and some other really amazing discoveries.
Wow, even I thought you were the original inventor, but let's not tell people that. But thank you for your time, Galileo. Stay out of trouble now.
Absolutely. Jeff, it was really nice to meet you.
Well, pleasure's mine.
Yeah, best of luck on your test, and wish you the best.
Thank you so much for your help. You've been really good.
Yeah, thanks again. Jeff, let's get out of here.
Okay. Here we go. Alright, okay, let's go. Yeah. So, where are we going now? Let's go through. Yeah, let's go.
No, you don't want to go through that door.
Why not?
Don't ask questions, Jeff. Okay. Come on. Only a couple more guys left.
Wow.
Okay. I think I know this one.
Really? I was starting to think you didn't have any brains up there.
Come on.
Hey, Doppler.
Hey, nice to meet you. You're Isaac Newton, right?
That would be me.
Okay. My professor, Professor Shapiro, talks about you all the time. You're definitely going to be on my final.
That's for sure. I am one of the most influential scientists of all time. I recently published Principia, in which I explain a lot of my laws of motion and universal gravitation. Have you read it by any chance?
I don't actually read, so no, I haven't.
Okay, well, I guess I'll try and sum it up for you. I basically formulated 3 laws of motion which describe the relationship between the forces acting on a body and its subsequent motion. So my first law is that an object in motion will stay in motion unless it's acted upon by an outside force. My second law of motion is that force equals mass times acceleration. And my third law is that for every action, there's an equal and opposite reaction.
What do you mean every action has an equal and an opposite reaction?
Try jumping as high as you can, Jeff. Now, how do you think you got off the ground?
Your third law of motion.
That's right. You see, when you jump off the ground, you exert a force into that ground. Now, in turn, the ground exerts an equal and opposite force, which propels you into the air. Now, tell me, Jeff, do you know what brings you back down to the ground?
Gravity, I think.
That's right, Jeff. You know more than you think. One day I was sitting under an apple tree, and I observed an apple falling from the tree. Now, as this apple came closer to Earth, it began to accelerate faster and faster as it fell. I thought to myself, there must be some force acting upon that apple causing it to accelerate. I called this force gravity. On Earth, gravity pulls all objects downwards toward the Earth, but it can also be applied universally. For example, how do you think the moon maintains its orbit around the Earth? It's because gravity pulls the two objects together, keeping the orbit in line.
But what determines how strong the attraction is?
Great question, Jeff. The strength of attraction is directly proportional to the product of the two bodies' masses and inversely proportional to the square of the distance between the two bodies.
Wow, that's pretty neat. What made you think of that?
Well, I studied Kepler's laws at Trinity College in Cambridge and pretty much just used my brilliance after that.
Cool. All right, well, thank you so much. It's been very helpful. I'll definitely be able to use this tomorrow on my exam.
No problem. Come visit again soon.
Catch you on the flip side, my friend.
See you, Doppler. Always, brother.
See you later.
Bye.
Alright, I'm really starting to panic this, man. I think I'm ready for the test.
Well, you definitely learned a lot at this point, but we still have one guy left, and he might be the most interesting.
Okay. What's his name?
Well, you might recognize him when you see him, but I'll let you meet him first. Be respectful now, this is one of my more recent friends, and you'd be hard-pressed to find someone more brilliant.
Alright, I know this one. This is Albert Einstein.
It is. Al, my good friend.
Oh, long time.
How are things?
What's up?
Nice to meet you.
I'm Jeff. I have a final tomorrow. I'm trying to pass. I need some help. I've already met a few other astronomers. I've met Newton.
Newton? Not much good his theories will do for you.
What do you mean?
Well, Newton's theories on gravitation aren't accurate at all. Like, what happens to matter when it approaches the speed of light? Newton doesn't account for this at all. Also, his gravitational laws can't be applied universally. Like, he has no account for what happens for when there's a strong electromagnetic field present. All his, laws on gravitation completely break down.
I have absolutely no idea what that means.
Well, my theories all are rather hard to explain, but basically they all deal with what happens to matter when it moves towards the speed of light. And my theory of special relativity is based on two principles. One, that the laws of physics are identical in all non-accelerating reference frames. And two, that the speed of light is constant in free space.
Okay, but what about your general theory of relativity?
My general theory of relativity is just an expansion on my special theory of relativity, which includes the gravitational force's effects on the flow of time and the shape of space. I have many field equations to prove this phenomenon. However, I don't think you'll need to know this for your test. I think that if you know that my equations and theories predict most of the gravitational forces in the world, in the universe, that would be more than enough.
I have absolutely no idea what that means.
I know it all is very complicated, but I'm sure that all you need to know for your test tomorrow is my famous equation E equals mc squared, which it means energy equals mass times the speed of light squared.
Well, that sounds good. Thanks so much for your help, Mr. Einstein.
Please, Al.
Thanks a lot, Al.
Anytime, my main man. Take it easy, guys. Best of luck on your test.
Thanks, Al.
Well,
Take
let's
care.
get you back home. You need to get a good night's sleep before this test.
Alright, let's do this. Wow, there was so much information to take in, but I'm happier I learned it that way. from their own mouths. You know what I mean?
Yeah.
It's I think I'm gonna do well tomorrow.
That's great, Jeff. You have to make us all proud. We're counting on you.
Are you? Why? For what reason?
Your happiness is our happiness.
What do you mean?
Jeff, we're just a figment of your imagination.
Well, I guess that makes a lot of sense.
Yeah, it does actually, but you need to get back to studying. You have a lot more information to cover before this final.
Alright, let's do this.
Pass this.
No, the test. Dude, why don't you freaking wake me? Better not be late.